Hello everyone, this is our pitch on the water efficient irrigation system for farmers in southern India. This is our team. I'm Ashik, Damien, both from MATE Civil Engineering, Andrew in Electrical, and Mingzi in Computer Engineering. This project is based on adapting to climate change where we chose to adapt to water shortages caused by droughts. The problem we noticed was that farmers in southern India are used to getting rain every year from monsoon season. Thanks to climate change, farmers are not able to produce enough crops and had to increase prices, which has affected the entire economy. Onion prices, for example, have increased by 300% because of this issue. So, our solution depends on reducing water usage so that they could produce more crops with less water. Now, Mingzi will talk about our design solution for this problem.
Well, research show that only 6 liters of water is needed to produce 1 kilogram of rice, but farmers are currently using 1,500 liters. So the solution we propose is an automatic irrigation system with a moisture sensor and a solenoid bulb connected to Arduino, helping to keep the usage of water at a much lower level. We researched that farmers mainly use rain-fed agriculture, and this allows tons of water to be wasted due to lack of regulation as well as evaporation. This gave us an idea to instead bring a proper under-soil irrigation system so that we could reduce this wastage. Now, Andrew would talk about the prototype design and testing parts.
Thank you, Eric. Our prototype uses a moisture sensor to test whether or not soil in a particular spot is dry. If it is, a valve is opened and water flows through some tubing and eventually ends up under the soil. After the sensor determines that the soil is wet, the valve closes. We tested our prototype on different plots of soil with varying levels of moisture and learned that the relationship between the moisture value determined by the sensor and the volume of water actually in the soil closely follows a logarithmic relationship. We used this data to set thresholds for when the valve opens and closes. All this goes to show that with just one sensor and one valve, we have already achieved an extraordinary level of efficiency in conserving water. But when it comes to improving our current prototype, there is a lot that could be done. Now, Damien will discuss future work that can be done on our prototype.
All in all, our group is very excited moving forward with this prototype. Our next step would be to add a water tank. This would collect rainfall from these floods along with a sensor which would measure the water level inside the tank. Next, we would add a humidity sensor. What this would do is measure the water vapor in the atmosphere and will allow us to predict our water usage more efficiently and correctly. And then our last step would be to add a UV light filtration system. What this would do is efficiently and effectively just filtrate the water. That way no bacteria, fungi, or other viruses which can damage the crops get through the pipes. And thank you for your time.